Next step, after balancing the charge in both the half reactions, now we have to see that the number of electrons added into each half reaction must become equal to each other. Here we have added 2 electrons, here we have added 5 electrons. That means in these two separate half reactions, different number of electrons are existing. Now we have to equalize that number. For equalization of the electrons in both the half reactions, you select any quotient and multiply the entire reaction with that quotient. So instead of selecting any one quotient, you simply exchange the number of electrons that you have added into the two half reactions. Here we have added 2 electrons, therefore multiply the second reaction with the 2. Here we have added 5, therefore multiply the first reaction with that 5. That means with this 5 we have to multiply this reaction. With this 2 we have to multiply this reaction. Therefore by exchanging the electron number, I am multiplying the opposite reactions. Therefore first I multiply the first reaction with this 5. The reaction becomes 5SO3 2 minus plus 5H2O gives 5SO4 2 minus plus 10H plus 10 electrons. Similarly, with this number, you multiply the second reaction. Now, 2MnO4 minus plus 16H plus 10 electrons gives 2Mn2 plus 8H2O. వస్తుందండి అది వస్తుందా 8H2. Now we have equalized the electron number in both the half reactions. After equalization, then the 2 independent reactions again they have to be added together and we have to derive the net reaction. For that, to derive the net reaction, now just represent the 2 reactions one below the other one. 5SO3 2 minus 5H2O gives 5SO4 2 minus plus 10H plus 10 electrons. There 2MnO4 minus plus 16H plus 10 electrons gives 2Mn2 plus 8H2O. Now add the 2 reactions with each other. During the addition, if any similar term appears this side and that side, we can cancel that similar term. Therefore 5SO3 2 minus. Next 2MnO4 minus. Next here 5H2O, here 8H2O. So all these 5H2O and here 5H2O will get cancelled. Here only 3H2O will be left. Similarly, electron number, this side electron number and that side electron number will get cancelled. Next here 16H plus, here 10H plus. Out of this 10 and this 10 will get cancelled. Here 6H plus will be left. Next here 5SO4 2 minus plus 2Mn2 plus 3H2O. This is the net derived reaction. After deriving this reaction, now if you count the number of atoms, if you count the charge, if you count the electrons, every type of the species have been equalized with each other from the reactant side to the product side. Yes. Next, balancing of the redox reactions through oxidation number method. oxidation number method. This oxidation number method is usually applied for any redox reaction in which neutral molecules participate. It can also be applied even for the reactions in which ions participate. So, for any type of this species, this reaction can be applied. So, let us take oxalate. This is oxalate. This is oxalate. Next, let us take potassium dichromate. This is potassium dichromate. This potassium dichromate will always act as the oxidizing agent, because the oxidation state of the central atom, that is chromium, is +6. Hence, chromium will always gains the electrons. Hence, potassium dichromate will always act as the oxidizing agent. Next, this oxalate or oxalic acid will always act as the electron supplier or reducing agent. This will act as the reducing agent. This will act as the oxidizing agent. Now, let us balance the reaction between these two species through oxidation number method. I am representing the oxalate as a C2O4 2-. Next, when K2Cr2O7 participates, the active species involved in the reaction is Cr2O7 2-. Therefore, I am showing only Cr2O7 2-. Now, let us conduct this reaction in alkaline medium. Now, the reaction is taking place in the alkaline medium. Now, in the alkaline medium, let us say this C2O4 oxalate has been oxidized into CO2. Next, dichromate has been oxidized to Cr3+. This is the net reaction that is taking place in the alkaline medium. Now, we want to balance this reaction through the oxidation number method. So, in this oxidation number method also, the first step is the identification of oxidation state of each and every species. Now, let us observe the oxidation state of the carbon here. The oxidation state of the every carbon here is +3. The oxidation state of the carbon here is +4. That means for carbon there is change in the oxidation state. Now, identify what type of change that is happening. For carbon there is increase in the oxidation state. Hence, we can say carbon is undergoing oxidation. Similarly, chromium. Observe the oxidation state of the chromium here, +6. The oxidation state of the chromium here is +3. Therefore, here +6 to +3. Therefore, here there is a decrease in the oxidation state. Hence, it is called reduction. That means one species is undergoing oxidation, the another species is undergoing reduction. Next, here in this oxidation number method, we need not split the entire reaction into two halves. Without splitting, directly we can balance the reaction. So, therefore, first, what is the first step to balance this reaction through this method? In the first step, first identify the atoms whose oxidation state has been changed. For which atoms oxidation state has been changed? For carbon as well as for the chromium. Since there is change in the oxidation state of the carbon and chromium, therefore, first you balance the carbon and chromium atoms. Before you start the actual process, you balance the carbon and chromium atoms. See, here two carbon atoms were shown, here only one carbon. So, by keeping suitable number before the formula, we can balance the carbon atoms. Similarly, chromium atoms also. Here two chromiums were shown, here only one chromium is shown. Therefore, first we balance the carbon and chromium before we start the actual process. oxalate plus dichromate plus OH minus. Here put 2, it becomes 2CO2. Here Cr2O7, you put 2, it becomes Cr3 plus. So now the oxidation state of the carbon and chromium are changing, and their numbers are different from reactant side to product side. Therefore, first we have balanced the carbon and chromium atoms. Next, after balancing the carbon and chromium atom, now identify the total charge difference of the carbon atoms and the total charge difference of the chromium atoms. Total charge difference. Here each carbon is in +3 oxidation state. Therefore, total charge is +6. Here each carbon is in +4 oxidation state. Therefore, total charge is +8. +8. Therefore, total charge difference is how much? 2 units. 2 units. Next, for chromium. Similarly, here for each chromium, the oxidation state is for each chromium the oxidation state is +6. This side each chromium oxidation state is +3. Therefore, total oxidation state is +6. Here total oxidation state is +2. Therefore, the total change in the oxidation state is 6 units. So first identify the total charge difference between the oxidizing species, total charge difference between the reducing species. For oxalate, the total charge difference is 2. For chromate, total charge difference is 6. 2 and 6. Next, in the next step, exchange these numbers. That means you keep this 2 in front of the dichromate. You keep this 6 in front of the C2O4. Exchange the differences. So if you exchange the differences, here we will get the 6 C2O4 2 minus. Next here 2 Cr2O7 2 minus plus OH minus. Next here we have kept the 6. Therefore, this side also we have to equalize the carbon number. 6 means total 12 carbons. Therefore, directly put the 12 carbons. Here 4 chromium atoms. Therefore, make this side also 4. 4. So now we have balanced the atoms which are undergoing oxidation and reduction. Next, after balancing the atoms, now we have to balance the oxygen atoms. For balancing of the oxygen atoms, count the oxygen atoms this side and that side. Here 4 oxygen atoms, here 14 oxygen atoms, total 18. 18. Next, you don't count this one, we will count it later. Next here, this side 24. Total 24 oxygen atoms here. Next, this side here, just 1 second. Wait. ఇక్కడ దాకా రాయచ్చండి, ఇక్కడ దాకా వస్తుందా, యాడ్ అవుతుంది ఇక్కడ, అందుకోసం ఇక్కడ ఇంకో స్టెప్ రాద్దామని చూస్తున్నాం. 24 plus 40, 38. Here 24 to 14. Okay, can I count this? Okay. ఇక్కడ ఇప్పుడు వస్తుందా కరెక్ట్గా? ఇక్కడ దాకా రాయమంటారా? Next, after balancing the heteroatoms, now we have to balance the oxygen atoms. For balancing of the oxygen atoms, first the total number of oxygen atoms on the left side as well as on the right side. Here on the left side 6 into 4, 24 oxygen atoms here. Here 2 into 7, 14. So 24 plus 14, 38 oxygen atoms are present. Let us count this oxygen later. 38. Here 38 oxygen atoms are present. This side 24 oxygen atoms are present. So therefore, which side excess of oxygen atoms are present? This side. This side deficiency of oxygen atoms are present. So how many oxygen atoms are deficient? 14 oxygen atoms are deficient. Therefore, first identify the side in which deficiency of oxygen atoms is existing. This side there is a deficiency of oxygen atoms. Then identify the number of oxygen atoms which are deficient. Here how many deficient? 14. Therefore, here 14 oxygen atoms are deficient. This side 14 oxygen atoms are excess. Therefore, now in order to balance the oxygen atoms in alkaline medium, add the number of water molecules which are suitable to balance the oxygen atoms. 6C2O4 2 minus plus 2Cr2O7 plus OH minus here 12CO2 plus 4 Cr3 plus 14 H2O molecules have to be added. This is separately one more OH group is there. For this OH group also include the water molecule. Therefore, total 15 H2Os. Now, you cross check the total number of oxygen atoms here. Here already 24, here 14, 38 plus 1, 39. Here 24 plus 15, so 39. So, oxygen atoms have been balanced. Next, after balancing the oxygen atoms, then we have to balance the hydrogens.